Okay, so the first thing that I do when I upload my images is I immediately put them into a folder that's just named images raw, and it's literally what I get from my SD card and I put it in here. Then from that list, I'll select out all of the images and I'll separate them based on what type of image they are. So I'll make a folder that just has my RGB images. And these images look like the images you would capture with something like a smartphone or a regular digital camera. And you'll notice that they'll look beautiful, normal images, and you'll see that they are saved as JPEG files. And there will be one of each image number. So this is 0, 1, 2, 3, 4, 5, all the way down to 588. And great, so those are our RGB images. And we separate them into different files because RGB images are saved differently than multispectral images. So multispec images are captured as TIFF files instead of JPEG, so that's the first difference. There's also changes in the resolution between the two different types of sensors because one sensor is capturing RGB, so it's looking at the red, green, and blue wavelengths at once. And our multispectral sensors are a single sensor that's capturing a single band. So we have a sensor for our green images, a sensor for our near infrared, a sensor for red, and a sensor for red edge, okay? So all these images are capturing the same area simultaneously, and then we're going to combine them into an image in our software, okay? So when you look at these images, you want to make sure that you have the same image 4 times. So we have image 0000 times 4, 0001 times 4, so on and so forth. Ideally, this number of images will be 588 times 4. You're also going to have a DAT file. Don't worry about that, but also don't delete this. And you'll see, again, all of these images are TIFF files, so they have to be processed and stored. I usually store them separately. The third type of image that you're going to have that you should separate out are your calibration panel images. And again, you'll have the same image 5 times. This is an image that's captured with a different sensor. Let me delete this. Okay. And you'll see you should have an image of the actual calibration panel and then this additional file. These images, you usually capture these images by placing this thing called the reflectance panel flat on the ground. You want to face it north and you want to take an image of it overhead with the drone without casting a shadow over it. So you kind of want to maneuver so that you're not casting a shadow on it. This thing right here, this gray part, is essentially a surface that has a known reflectance, and it's been calibrated in the lab. So then we can take that known reflectance and relate it back to your images. And on top of your sensor, you have that sunlight sensor. So it takes the data from the sunlight sensor, combines it with the image from this calibration panel, and it essentially adjusts your images based on how the amount of light changed throughout the flight. The point is you just need to get a nice picture of this surface right here. There are some numbers on this panel. You need to record them and have them handy when you're processing on Pix4D Mapper. You don't really need to know any of this information for Pix4D Fields because the process is done automatically for you. But just so you know, if you ever see something that asks you for albedo numbers or reflectance values from your panel, this is what they're talking about. And from what I can remember, you have to convert these numbers to nanometers. I think they're shown in centimeters. Okay, so now you have all of your images, everything separated out and formatted. So now you're going to open up your Pix4D Fields. You're going to do a new project. And you have a few options. The first thing you want to do is just make a project. We're going to make 2 different projects, one for your RGB images and one for your multispectral images. So we're going to start with the multispectral. You can enter a description. If you want to add more information about to your project, you can always go on here and then it has a little settings tab and you can, for example, select the crop type, the crop variety. This is important if you're doing ag. You could do this if you're trying to separate them into different areas or if you want to separate things like ponds and lakes or something like that. It's not really something that's super useful to us, but some people might find this interesting. You can also look at your log files for your project here, etc. Back in here. Okay, so now we want to import some images. So you have the option of importing satellite data, as well as images or folders. So I'm going to do images just so that we can see what we're working with, but folders is usually pretty nice because you just batch upload everything. So here we go. Multispectral images, and we just do a little Control A action, make sure that everything is selected, and then we can open them. It's going to take a second to upload all of these images. Once everything's processed, you'll get a screen that looks like this. And so these are your two processing options. The first is fast processing, and this is essentially what you want to do when you get out in the field. If after you fly, you want to plug in your, upload your images, and you want to run this processing so you can make sure that all your images were actually captured, to make sure that your images weren't too noisy or blurry because it was very windy, or that for some reason they didn't capture GPS data. It's nice to be able to generate a low resolution coarse version of your orthomosaic, and that's what this fast processing is for. When you get in the lab to actually use these data for research, you want to do something called accurate processing, and this will essentially run your parameters at full resolution. It's going to take longer, but it's going to give you much better quality data. You want to include the weather conditions for that day, so make sure you write it down somewhere. I looked it up online, and the day you flew was clear skies. Then you have the option of processing your data at different resolutions. So you go from low all the way to full. This right here, GSD stands for ground sampling distance, and that's essentially the unit of measurement per pixel within your orthomosaic. So at full resolution, we're about 0.1 centimeter size pixels, or 0.1 centimeters per pixel. And if you go down and you make it a lower resolution, you can end up with 100 centimeters pixels for your orthomosaic. And honestly, that might be good enough for you. So some people just want to create a very rough orthomosaic that gives them an idea of the image and they want to do it quickly, then you can do it at 100 centimeters per pixel. The other reason why this might be helpful is if you're, for example, comparing to satellite imagery, and so you're trying to if you're trying to match your pixel size to the size of satellite imagery. This is pretty relatively limited on this software. When you go on Pix4D Mapper, you can actually put in the number for the ground sampling distance. On this software, it kind of seems to, well, actually, this one goes at pretty regular intervals. But if you want to get really specific and do like decimal places, you can specify that on Pix4D Mapper. That's not really useful for the purpose of our research. And if we did want to downsample, we can do that on GIS, which is where I would recommend that we do it. So don't worry about it. Just leave it at unlimited is the point of that ramble. Full blending is a technique used to essentially like blend together the scenes between the different flight paths. I've never used this and I don't really exactly know how it works, so I'm not going to enable it for now. And then radiometric correction is what we're going to use, or what's going to be enabled for us to use our calibration panels. You want to have this on no matter what, because the drone can calibrate to a certain degree using the sunlight sensor that it has on top. So you want to have this on. When you process your RGB images, you will not have the option to enable this, okay? So just that's okay. Okay, so you can click apply, and you'll see that you'll have your grid of all your images displayed on your map. If you click these individual dots, these are actually your images. And you'll see that the first line of information is the GPS coordinates. And the second line is showing you your image names. And you can see this is the same image 1046 for the green, red edge, near infrared. Okay, so you want to make sure that you don't have to make sure you don't have to click all of these, but if you're looking at your multispectral image and for some reason only 2 or 3 of these are showing up, something happened when you did your image upload. So just give those a quick look before you start processing. If you do have calibration panels, this is the time to add it. So you can add more images, and you can do import images. And then I would go in here, go into your calibration panel folder, and then I would just open your calibration panel images. There is a chance that this won't recognize these calibration panels because these calibration panels were captured with a different type of sensor. So there's a chance that it's not going to like it. But in theory, this is how you would do it. Okay, so I uploaded the reflectance targets, and you can see here that it says that reflectance targets could not be found. This is simply because they're using a different sensor. When you do this yourself, there should be a notice here that says that your targets were detected, okay? So once you see that it says that your targets are detected, if you're using them, and you make sure that all your files are TIFF because this is a multispectral, then you can start processing. If you decide that you need to change something about from your processing parameters before you start, you just click this setting button again, and it'll bring back those processing options. Okay, so now we just have to start processing, and this is going to take a little bit. Okay, so once your data is done processing, your screen should look something like this. It'll automatically show your orthomosaic. You can turn your layer on and off by clicking it, pretty straightforward. You're also going to get something called a surface model, and this is essentially an estimate or a representation of elevation. So if we had like a bunch of buildings and trees and objects, it would be able to give us an estimate of their location and how high they were. This isn't really that helpful for our purposes. You can see it works for like trees and stuff like that here. I would recommend looking at your orthomosaic and then going here into info just to look at the details about how your processing went. You'll learn things like the ground sampling distance of your finished orthomosaic, which is 11.28. And you want to record this for publication because you're going to need that. It shows us the wavelengths that were considered, which is correct. Your sensor does not monitor the blue wavelength, so this is correct. It shows us that it was able to conduct a radiometric correction. And from what I was reading, you actually don't need to conduct a radiometric correction of a reflectance target for your particular sensor. And I'm going to link that somewhere in the description. But I would still collect a picture of the reflectance target because sometimes you need it for publication, and also it could help make your values more accurate, which is what we're looking for. Okay, so everything here looks good. It shows us that reflectance targets didn't work, but when you use your targets, it should say that they were incorporated. Some of the other options that you have here are options to calculate an index. For the most part, we're going to calculate things like NDVI, GNDVI. We don't usually calculate things here. Stephanie and I and a lot of people who do this, we usually calculate our indices in GIS. You can do it here, especially for your purposes, but for doing things that are a little bit more rugged, and I would suggest doing it on GIS. These are some of the default options. If you want to calculate something that's not in here, you can just create a new index and then write your formula. So let's say we want to look at the reflectance of the green band. You can just write green, whatever, and you can actually preview what this looks like, okay? So this just gives you a preview of your index, which is pretty sweet. I'm not going to do that. The other options that you have here are the magic tool. The magic tool is essentially to remove noise from your orthomosaic. It has like a range of values that it's looking for that show you, that tells the software that what you're looking at is an error or noise. We're not going to use that. The other option is donation. This is more for classifying things. We're not going to use that either. Okay, so now we have all of our information. It's done. So now we can export it. You have different options. I would always export your PDF report. This is just going to tell you information about your processing and the information that was inputted. We're going to do layers, and we're going to do our orthomosaic. And we're going to, okay, you can do both of these if you want. We will use the data.tiff for processing. But especially when you do your RGB images, you can do this one, the RGB one, which is just for displaying. But for analysis purposes, you're going to use the .data.tiff that has everything. Okay, and then we're going to keep the image scale at 100, and then we're just going to export. Once it's done processing, it'll automatically show your results in here, okay? And those will have the same name as your file, as your Pix4D Field project, okay? So we have our Pix4D multi-clemmer. Great, so we're done with that processing. Now we need to run the RGB images. So let's not forget that we have to process those separately. So we need to start a new project. And I literally name it the exact same thing, only instead of multi, I say RGB. So this is, okay. Then we're going to do the exact same thing. So we're going to go in our folder. We're going to find our images. They're all in here. And it'll upload it. Same thing. Will take a second. Okay, and this is the same thing now. So we're going to do accurate processing. It doesn't matter what the weather looks like, because it's not going to be an option for our calibration. We're going to do full resolution processing. Again, we're not going to activate the full blending because I don't exactly know how it works. And you'll see that for your RGB images, you're not going to be able to apply this radiometric correction. Again, that's normal. And then we're just going to do apply. You will see all your images again, and you'll see that when you click on them, they'll just be one image, your JPEG, okay? You'll see that instead of being TIFF, now they're JPEG. They're all the RGB images. There's 588 of them, so they all loaded properly. So we're cool. All we have to do now is to start processing. Okay. Okay, so now the RGB data is done. So we have our orthomosaic again. We have our surface model as well, which will take a second. Okay, so here's our surface model. We're not going to worry about it too much. At this point, you can also calculate some vegetation indices if you want. Again, we usually do this in GIS. And you have the same options. You'll see that when you look at your report or your information, you'll have different information. You'll have a different ground sampling distance. Again, this is important for reporting it for publication. And it'll give you some other information. At this point, all we need to do is export it. Again, we just go to layers. We're looking at our orthomosaic and continue, and we're gonna download everything or export everything, but for analysis, we wanna use our data file, and for actual visualization, we can use our RGB file. We're gonna do 100% image scale, and then we're gonna export it. And it'll have the same name as our project on Pix4D Fields. Now you've opened GIS Pro. The first thing I would do if I were you would be I would open up my settings and I would go to options and then to your map and scene. And I would add a spatial reference to your map. And essentially what this is referring to is the way in which GIS is taking a 3D object, which is planet Earth, and displaying it in a 2D surface, which is, in this case, your computer screen. So you need to tell it how you wanted to do that. And for us, we're going to use this one, the NAD 1983 UTM zone 16N. You just have to, when this opens, you will probably not have anything pop up here. Just type this into your search bar and it'll pop up. This will essentially make the map focus all over Alabama. It would be something different if we were looking at the entire planet or if we were trying to look at the entire United States. So just make sure that's selected and you can click OK. And then we can actually go in and create a new project. So just click new map. And then you want to name it GIS, where you collected your images. where you collect your images, your date, and then which sensor you used. And then you want to save that in the folder that has all of your images. Okay. And you want to click create a new folder for this project. Okay. So this will open up a new map. Okay. And the first thing we want to do is to make sure that our reference loaded properly. So we want to go to, oops, I need to do it slower. So you want to, right here, you have your contents pane. So this is going to be all of your layers in your map. Automatically, GIS is going to add this world topographic map and world hillshade. If you want to see those, then these would disappear. If you don't like these and you want these to be different, you can go to map and base map, and then you can change what the background looks like, which is pretty nice. Okay, so now we have our map. You want to right click it and then go to properties. And here you can see a lot of the relevant information for the map. You can change its name. You can see what the units that it's displaying are. So in this case, it's decimal degrees. You can set scales, etc. You want to go to your coordinate system, and you want to make sure that the NAD 1983 UTM zone 16N is selected. This means that what you did before was applied properly and that everything's showing up the way it should be. Okay, so now we have made sure that everything is working correctly. And now we're going to add our orthomosaics that we exported from Pix4D Fields. So you can go right here in your map. You're going to go in your layer section. You're going to add data. You're going to navigate to your parent folder, so the one that has all of your images and all of your other working documents. And you're going to go to your Pix4D results. So let's start off of our RGB results. And you're going to see we're going to have a data and then an RGB file. We're going to go with the data file. And you're just going to click on this one and open it. But if you want to see what's in it, there's actually more layers within this one image. So this is going to be our red, green, blue, and then our alpha layers. We're going to only use the RGB layer for visualization in this particular example, but if you wanted to do calculations, you could also download these individual bands. I only want to see the image as a reference, so I'm going to just click the data tip and click OK. And that should import our RGB band, our RGB orthomosaic. Now it looks a little bit funny, and that's because it doesn't really know which bands to assign to, like which color to assign to each band. So you have to tell it. So all you have to do is right click on these and then make them match. And there we go. There's our red, green, blue map. Okay, so this is our RGB. These are JPEG. This is a TIFF file created from JPEGs. So now we're going to import our multispectral orthomosaics. And these ones we are going to download the individual wavelengths or the individual band files. So we're going to click data, and then we're going to just click one and click all of them, and then OK. And that should import all of our layers. So here we have just displaying just the red edge, just the red, just the near infrared, etc. Okay, great. Now we need to upload the locations of where you collected your water samples. This is usually where the GPS, the handheld one, comes in handy, because we go out there and I collect a GPS reading everywhere that I collect a water sample. We might have to get a little bit more creative with doing this process for you. Maybe we'll just estimate the location of the GCPs or something. We'll talk through this. But for the purpose of this demo, I already created a CSV file that contains the GPS locations of your water samples that you theoretically collected. So to add those data, you have to go to add data and then XY point data. And it'll open this tool called XY table to point. Now you're going to upload your data file. And you can see here, I already made a CSV file with our sample locations. I'm gonna click OK. We're going to give it a name that's easy to follow. So I just did samples, Clemmer, and then the date. And then you're going to add your X field. And if you are like, oh, I don't know what the X field is, it'll tell you it's longitude and then latitude. And then your Z field is essentially your altitude. And this isn't required. It's going to automatically give you a coordinate system. You can leave this, it's automatically detecting it. What you do want to do is go then in environments. And then for your output coordinates, you want to make those match the map you're currently working off of. So you just have to go in there and click current and it'll automatically upload it. And then that's it. Just click run. And these should display on the map and they are there. They're a little bit hard to see. So if you ever want to change or modify a symbol, you can click on it and that'll open up the symbology. And so then you can easily change. You can see it easily changes the symbol. So let's try to do something that's easy to see. Okay, so there are my theoretical sample points. If you're like, oh, I'm not sure what these are named, these have names to them. So you can always add their labels right here. If when you upload your points, you should always open up your attribute layer. So just click on your layer and then right click, and an attribute table. And this will essentially show you your data table. So we have the basics. So the name of your ground control point or your sample point or whatever you are collecting. And then usually I have like some notes about the location if there's something I wanted to consider while I was processing, such as the like really dense macrophyte cover, or if there was an aerator that was on close by or something like that. Okay, so those are our data points. And now we can actually start our processing. So we need to calculate our vegetation indices. To do that, we have to click on the Analysis tab, then Tools, and then we need to use our raster band calculation. Actually, I'm going to show you a different way to get there. So you can search this, or you can also search through all the toolboxes that GIS has to offer. There's a lot of them. For what we're going to be doing, we're mainly going to be using the image analyst toolbox, which makes sense because we're working with raster data. And you're going to click map algebra. And here we have a tool called raster calculator. Just make sure that if you do search this, you click the one that says image analyst tool like it does here. There's another one that's like a spatial analysis tool. You don't want to click that one. So click this one. And then essentially here you can calculate any vegetation index that you want. So for example, we could calculate NDVI, which I know is NIR minus red divided by NIR plus red. And usually for the naming, I'll include the vegetation index. I'll include essentially all the data because sometimes I will be calculating the same vegetation index from different sensors in the same map. And I want to make sure that I'm not getting messed up. So it's just really important to keep track, especially once you get more and more complex with your data collection. So we're going to just click run. Okay, so you have created your NDVI. It's kind of hard to tell what this means based on the symbology. So you want to make sure that when you open or create a map, you're looking at it really critically from the beginning. So I always change the color scheme of things like vegetation indices to something that's very logical very early on. So for example, is NDVI, I know that the range of NDVI is 1 to -1. So I know that this makes sense. And NDVI should be the strongest or brightest or greenest where there's a lot of photosynthetic activity. So I can look at my NDVI and look at my RGB and see that it makes sense. The parts that are greener are the parts that have the vegetation. So I am confident that this was processed correctly. And now we want to actually extract the information or what this NDVI value is for this point. Now we don't do just one point. We want to extract the data from the buffer around this point because there's a lot of variation between these pixels sometimes. So we want to make sure that we're capturing a range of pixels, not just one, if that makes sense. So to do that, we need to create something called a pairwise buffer. If you're in the analysis bar, this one's actually the first one that pops up, so it's very convenient. You're going to click your samples, and then you are going to rename this based on the naming structure. Okay, so you have your output feature class, which is just samples with the buffer size. You can't put periods in names for these types of outputs. So I just put 0.5 and then buffer, the location and the date. This is your distance value. So how big you want your buffer to be. I put 0.5 meters. This is kind of standard what I've been using. There are some papers that I can share about this. The buffer size will kind of depend on what your data looks like. But this is just kind of standard for now. I would do the planar method, no dissolve, and then 0 meters for the offset deviation. And then I just ran it so you can see that it'll produce this layer right here. And don't freak out when you run it because if you're in full out view, you're not going to see it. You have to really zoom in order to see your buffer. There it is. Okay. So don't be like, ugh. It's a good idea to always look at your buffers when they're created, because you want to make sure that you're actually not catching any land pixels by mistake or that it looks funky. So just go in and look at each of your individual buffers to make sure everything looks okay. Okay, so there you are. So there are your buffers. And now you have to actually extract the data from these different samples. So you have to go back to your tools and you have to select the zonal statistics as table. Okay, and again, you want to do the image tool. And now we're going to use our input, our feature zone data. So that's going to be our buffers. This is your zone field. So this is what you're going to use as your ID. So that's your GCP name. Your output value raster is going to be your NDVI or whatever vegetation index you calculated. And your output is going to be your vegetation, your vegetation index name. So this is going to be NDVI for summer, and then your date. It seems like a lot to write this every time, but it gets really confusing very quickly because so many things can be collected at the same flight. Cool. So that's all your information. So we're going to calculate the buffer 0.5. We're going to calculate averages for this particular vegetation index. And you can either do all your statistics, so it'll literally give you a table of all the information about the pixels inside those buffers. It can be a little bit time consuming. So I'm just going to do the means. And I'm going to leave these two options unchecked. And then I'm just going to run it. And then we'll see that at the bottom of our contents pane, we'll have a new standalone table. We have to open that up and make sure that it looks okay. So here we go. So we have the mean of the pixels within this point is this, and we have our data. So then the only thing left to do is export it out of GIS to actually analyze it somewhere like R. So you want to go back to your geoprocessing pane and do table to Excel. You're going to take that standalone table and you're going to add it to your result tables VI buffers folder, which you've already created. And you want to name it the same thing as your table. Okay, so then you have your name. So again, this is up to you, but for our lab, this is how we do our naming conversion. And then you just click save. Now you actually have to run it and click run. And if you go back to your parent folder, you'll see that in the results table, there should be an Excel file. And here we go, we have our results. Usually at this point, then I add what vegetation index this is. You can also do this in GIS if you want. So I write NDVI. And then when then I repeat these steps for all my vegetation indices, and then I merge everything into one data sheet so that I can analyze stuff on GIS. So this is the quick and easy way of doing this. The last thing that I want to show you is how to make like a quick and easy map on GIS so that you can actually make a pretty version of your map for you to put on a poster or something. You can go to insert and then new layout. There are actually, let's do this one, import layout. There's like pre-made layouts for you to use, which is really nice. Let's do this one. And then all you have to, it gives you this nice overview map. So this is your map frame, so the big one. So right now it doesn't have anything, it doesn't know what it is. So you have to go to your properties. And then you can tell it that you want it to be the map that has the drone data in it, which is called map for this file. So you just click map and it'll display this map. It's not showing it properly. So what you can do is you see your layers here on the left-hand side. You can go right click and then, oh, no symbology. You can go right click and then zoom to layer. And then there's your layer. You can use your NDVI or you can use your RGB, whatever you prefer. If you want to have your pawn names, you just have to activate the labels. It's kind of hard to see them right now, so you can always right click that and then go to the symbology and then do something maybe like adding a halo to make it easier for them to read it. So there we go. We have a nice scale bar. You can change if it's miles or kilometers. If it's up here on your designs, you can change it to meters or kilometers or whatever you want there. You can change your title. So this is Clemmer. Okay. And this is essentially your service layer credits. So essentially the credits for the background layer. You can keep those, or you can remove them. The other last thing you might want to add is a reference map. So this is your map frame, and then this right here is what they call the overview map. And you can go to map again, and then it'll show a smaller version of it. You can go to, okay, sorry. So you can click on it and then go to activate, and then you can kind of zoom to it, however close or far away you want to be. And for this one, you can, yep, just leave it like that. And then you can go to layout and then close activation. And then in the overview map, you can actually turn this off, and that way you just have a reference map. That's pretty much it. That's just making like a quick and dirty, easy layout. You can mess with how you can mess up all these properties, but if you just want something easy that is pretty much complete, you can do this and you will be good. If you want to export it, so all you have to go do is go to share, export layout, and then do this. Once you do this, it's going to tell you to save. Just make sure that after you save, you actually click export. Saving it doesn't actually save it to your computer. It's just saving the name that you gave it. That happens to me sometimes. Okay, so that's pretty much it. That's like the quick and dirty version of how to process data. If you have questions, just let me know.